Hi, welcome to this Confusion Matrix Part 2 session. In the previous video, we touched upon what is confusion matrix, why to use confusion matrix, and what is true positive, true negative, and so on. Importantly, touched upon multi-class classification related confusion matrix. In this session, we'll take a deep dive in understanding various metrics that were derived from confusion matrix, which will be used to assess the accuracy of the classification model. Just a quick recap. The confusion matrix is a table that is often used to describe the performance of a classification model. The confusion matrix compares the actual outcomes with the predicted outcomes. The rows are labeled with actual outcomes while the columns are labeled with predicted outcomes. Now let us move on with understanding various metrics derived as part of confusion matrix such as accuracy, precision, recall. So what is accuracy? Accuracy is nothing but the out of the total number of samples, how many number of samples were predicted correctly. Mathematically, we define, the accuracy is defined as true positive plus true negative divided by all the values. All these will. Let's take for example, in the case of email classification model, the confusion matrix, let's assume that the confusion matrix looks like this. So in this case, the objective of the email is to predict as many spam email as possible. But in this case, if you look at here, 2 emails were correctly predicted as spam email and 1 email was correctly predicted as non-spam email. And 1 email was wrongly predicted as spam, whereas it is actually a non-spam email. But if you plug in these values into this one, we get the value for the accuracy as 50%, 3 out of 6. True positive plus true negative divided by all these values. The accuracy is 5%, 50%. In this case, the classifier is doing a pretty decent job. So in this case, the data set is balanced. If the data set is balanced, we can use accuracy. If you care equally about true positives and true negatives, then accuracy matrix is the one you are supposed to use it. Okay, so a perfect model would be that it should have 0 false positive and 0 false negative, but this is practically impossible in reality. Now let us look at the confusion matrix with different values for the same email classification model. In this case, we could see that 0 true positive value and 0 false positive value. And if you plug in these values here, you get the accuracy as 99.56%. So our model is saying I can predict both spam and non-spam emails 99.56% of the time. Is that correct? Is that statement correct? It is quite opposite in this case. Accuracy is misleading. Though the accuracy looks so impressive, it is not even detecting even a single spam email. The model failed to predict even a single spam email, but it says the accuracy is 99.56%. The reason is the data is imbalanced here. The data is imbalanced here. What is imbalanced data? So here, how many number of spam emails are there? How many number of non-spam emails? Non-spam, we could see that the total number of non-spam emails are 2075. And the total number of spam emails, if you see here, 9 plus 0 is 9. The non-spam emails, the total number of non-spam emails are much higher, much higher than the total number of emails that were spam. Hence, this is called imbalanced data set. So this is my majority class in this case. Since I have more number of observations that are there as part of non-spam, this is called as majority class. This is called your minority class. Minority class. Hence, this data set is an imbalanced data set. So in this case, if you use accuracy, it is misleading. It will mislead you. So if you look at this here, there are 2075 patterns that are non-spam and only 9 patterns that are spam. So in this case, the classifier easily biased towards the non-spam class. Hence, do not use accuracy if the data is imbalanced. Using accuracy as a defining metric for the model does make sense intuitively, but more often than not, it is always advisable to use precision and recall too. But in this case, accuracy doesn't make any sense in the case of imbalanced data set. So now the question is, then how do I measure the model accuracy? Which metric should I use in the case of imbalanced data set? So that is where there are two other metrics are available to measure the imbalanced data set related models accuracy. So one is precision, other one is recall. Now let us take a look at what is precision. The precision, we can compute the precision like this, right? So using this formula, we can compute the precision. So what it says is, out of the total predicted positive, how many number of the emails were correctly predicted? Out of the total predicted spam emails, how many of them were actually spam? In simple term. So look at this confusion matrix. In this confusion matrix, right, these are the predicted value of this total predicted positive value. The true positive plus false positive, how many of them were true positive? That is what precision says. Precision is a good measure to determine when the cost of false positive is high. Now let us use this example to understand the precision clearly. Look at this. In this case, my model predicted 6 people are having COVID infection. Out of the 6, 1 is false positive. Okay, so the formula for computing the precision is true positive, right? True positive plus false positive. So the true positive is 5 here, and again the denominator 5 plus 1 false positive, hence the precision is 0.83. So what we can infer from here is, higher the precision, lower the false positive rate. Supposing you don't have the false positive, let's say you are removing this person. So 5 divided by 5 plus 0. So in that case, it is 1. The higher the precision, lesser the, in this case, no false positive rate at all. No false positive rate. So what is higher false positive cost? What is higher false positive cost? Before that, now let us use the precision metric in this case. Okay, so what is true positive? What is the formula for precision? True positive divided by true positive plus false positive, 0 divided by 0 plus 0. That is what the that is what the value for the precision. It is 0. So the precision metric, if you use the precision metric in this case, the imbalanced data set, it tells us very clearly none of the emails were predicted as spam. The accuracy is 0. When you use precision metric, it tells us very clearly the accuracy is 0. Whereas when you use the metric accuracy, it gives us a wrong picture, whereas precision gives us the correct picture. Okay, what's this? We can use precision in the case of the false positive cost is high. So what do you mean by higher cost, false positive cost? So in the case of email classification, the false positive value is very high, which means the non-spam emails are predicted as spam email. The non-spam emails will be pushed to your spam folder. In that case, the email user might tend to miss out the important emails. In this case, the false positive cost is very high. It cannot be affordable. In that kind of situation, precision can be used. And next we will see what is recall. If you look at this confusion matrix, of this total actual positive, how many of them were true positive? So the mathematically we define the recall as a true positive divided by true positive plus false negative. To fully understand the effectiveness of the model, we must examine both precision and recall. Unfortunately, precision and recall are often in tension. It's kind of a tug of war. That means, right, increasing the threshold will typically increase precision and decrease recall, and vice versa. It is almost impossible to have both precision and recall. To understand this better, let us look at this example. Let's say I have 30 people. I have a COVID classification model. My COVID model assigned probability for all these 30 people. Now, let us try to understand how does increasing the threshold can improve the precision and decreases the recall. First of all, let us try to understand what is threshold. What is threshold? See, in the case of logistic regression or any classification model, the model assigns the predicted probability to all the observations. In our case, all the 30 individuals, my model assign the probability. Some people, the probability is very high. For example, for these people, you say, take this person and this person, the predicted probability is 0.99, 0.97, 0.96, 0.95. These are the probability for these people. Hence, these people are more likely to have the COVID. And whereas conversely, on the left side, if you look at these people, my model assigned the probability is 0.0003, 0.004, something like this. Those people have lesser probability. They are less likely to have the COVID. Those people have higher probability. They are more likely to have the COVID infection. So we can use the probability as it is, or we can convert this probability into binary values. How do we convert the probability values into binary values? That is where we'll be using threshold. Okay, now let us look at, there are two scenarios. Now let us look at first scenario. For all those people, the predicted probability is, more than 0.75. Then we are consider those people as having COVID, otherwise non-infected people. And in the second scenario, we are decreasing the threshold. The threshold value is 0.60. Earlier it was 0.7, in this case 0.75, here 0.60. Those people predicted probability is more than 0.60. They are considered as COVID people and otherwise non-COVID people. This is how we are converting the probability into binary value. For that we need threshold value. The threshold value, how do I decide the optimum value for threshold? That we will discuss it in the next video. At this moment, understand what is the impact of adjusting the threshold values, increasing and decreasing. What is the effect of increasing and decreasing the threshold value? So in this case, we have some misclassification also. The black colored people are false negative, and the amber colored people are false positive. Let's say if it's okay, in this case, in scenario 1, we have used the cutoff value is 0.75. Those people predicted probability is more than 0.75. They are considered as COVID people. This is my cutoff value. This is my 0.75. The threshold value is 0.75. Those people have the predicted probability more than 0.75. They are considered as COVID people, COVID infected people. On the left side of the threshold value, these people are considered as non-infected people. When you plug in this value to both precision and recall, we could see that the precision is 0.88. The true positive is 7. 7 people are having true positive. One person is having false positive. Hence, true positive by true positive, false positive, the precision is 0.88. When it comes to recall, in the denominator we can see false negative. The false negative is increasing it in this case. The false negative increases. In this case, we have 4 black colored people. These people are false negative. Okay, so 7 plus 4. So hence the recall is 0.64. Since we increase the threshold compared to the scenario 2, the precision increases whereas the recall decreases, and also the false negative increases and false positive decreases. So why the false negative increases? False negative increases because anything less than this threshold value, we consider them as non-COVID people. Even though these black colored people, right, have COVID infection, just because of my threshold value is more, these people are falling on the left side of the threshold, right, true negative. And false positive is decreasing it, right? So why false positive decreasing? Because the higher those people with, see, these people are having higher probability, right? The model assigned higher probability to these people, but still there was some kind of false positive. But the compared to this, right, the false positive is decreased here, but whereas the false negative increased. So now let us look at the effect of decreasing the threshold value. Okay, so in this case we have decreased the threshold value to 0.60. So earlier this line was here, now it got pushed to the left side, pushed toward the left side because of the decreased threshold. So what will happen is even the good people, the healthy people, could also fall on the right side, just because I moved this, I dragged this on the left side. So even the good people, that means the false positive can increase in this case, and false negative will decrease because the bad people, the unhealthy people, gets moved on the right side. Hence the false negative, look here, in the previous case the 4 false negatives were there, 4 false negatives were there. So but in this case, since you drag this towards the left side, the 2 false negative people got moved to the right side, hence they became true positive. And false positive also, in this case it increases because the good people also moved on the right side, hence the false positive increase, and the false negative decreases if you decrease the threshold. So from this what we can infer is, as we decrease the threshold value, the precision decreases whereas the recall increases, and the false positive increases and false negative decreases. That is what we can infer from here. So recall also can be used if the false negative cost is high. So when the false negative cost is high, supposing in the case of banking transaction, if the false negative values are high, which means the model wrongly predicted the fraudulent transaction as the non-fraudulent transaction, what will happen? It will have a serious impact. Here you will incur, the bank will incur loss, irrecoverable loss. On the other hand, if the model predicts higher false positive value, so that means the model wrongly predicted the normal transaction, fraudulent transaction. So in that case, there is no loss in money. There will be a inconvenience, but still there is no chance of money loss. So in this case, the false negative cost is very high. So you can use recall in those kind of situation. Now let us look at work on this quiz. So what is the answer for this quiz? Consider two models A and B. A and B. In this case, the answer is B. Okay. The model AS, let's say you have model A and model B. You computed the precision recall for both model A and model B. Compared to B, model A has better precision and better recall, right? So in this case, model A is doing good job. In this case, model A is doing good job. In the hope you enjoyed this video. In the subsequent video, we'll discuss about what is F-score and what is ROC curve, precision and recall, area under the curve. We'll discuss it. If you like this video, please do like, comment and share this video. If you are new one to this video, please consider subscribing to get notification for new videos. Please post your answers, comments and technical questions in the comment box so that I can get a chance to incorporate your feedback.